Right, so this is the second clip here, and what we've got to do next is find out this angle here, because normally we find the angle of the force relative to usually the horizontal. So there's the horizontal, so we're interested in this angle here. I've already found out more accurately that this is 13.41 centimeters. So I could say that that's now 13.4 newtons. Because I've got a scale here, I've said 1 centimeter is a newton. I can say that the force here, the resultant force, is 13.4 newtons in a particular direction, this angle. So I can actually call that newtons. I need to find out this angle. Now you're better off using the information that you were given originally, which was 6 and 12 newtons. So the opposite side here is the same as this length here, which is 12, and this is 6. So therefore I can say the opposite is 12 and the adjacent is 6 newtons. I could use this figure, but I'm going to get a slightly more inaccurate answer, because each time you find the value you're adding some error to that particular thingy. So, based on our trigonometry work we did last week, we know that we've got an opposite and I've got an adjacent, and we know from our trigonometrical rules that opposite over adjacent is tan. So I can say that tan equals opposite over adjacent equals 12 divided by 6, and that comes to 2, obviously. And I need to find the tan of that. I need to find theta, so I could say that's tan theta. So theta equals 2. So the angle tan theta equals 2. So theta equals second of that. 2 second of 2 is 63.43 degrees. So I know that that is 63.43 degrees. Okay, so that finishes that off. The resultant force is 13.4 newtons at an angle of 63 degrees to the horizontal. And that's that. So let's have a look at a couple of other examples then. If I have a force in that direction, see, I don't need to use graph paper anymore now. I can just do these on a page. If I've got a force here of 150 newtons in that direction and 200 newtons in that direction, well, if I draw a little parallelogram, then I know that that's going to be 200, isn't it? And that's going to be 150. If I draw that, then I know that a squared equals b squared plus c squared equals 150 squared plus 200 squared. So a equals square root of 150 squared plus 200 squared. And that all comes to, on my calculator, I go 150 squared plus 200 squared, and that comes to 62500. I find the square root of that, that comes to 250 So there we've got 250 newtons is the resultant force of those two forces, horizontally and vertically. 250 newtons. Now I need to find out this angle with the horizontal. And we found out last time that tan is the easiest one to use. Tan theta equals opposite over adjacent. This is the opposite, and that's my adjacent. 200 divided by 150. That comes to 1.33. Recurring. So theta, second tan, is 53 degrees. 53.13 degrees. So that becomes 53.13 degrees. Okay, so that's 53.13 degrees at 250 newtons. Have I got time for another one? Possibly. Let's try this one. $760 newtons, 500 newtons. There we go. Draw a line. A equals the square root of b squared plus c squared. Do that on the calculator. $760 squared plus 500 squared equals that. Square root of that. That comes to 909.72 newtons. So I've got 909.72 newtons in that direction. Now I need to find the angle. Tan theta equals opposite over adjacent equals $500 divided by 760. How are we doing for time? Got 1 minute. 500 divided by 760 equals 0.65. So the angle is 33 degrees. .34 degrees. Okay, so there we are. We found out the magnitude of the resultant force, and we found out the angle of the direction of that force. So we've worked out what we call the resultant force. Okay. I'll put a couple of examples on Solr for you to have a go. Thanks very much. Bye.